Good morning, everyone. My name is Gnanendra Dathathreya. So we're going to talk about Cloud Detour, which is chaos engineering automation tool that we developed in Capital One, and we plan to open source this one in the second half of the year. Right. 3 years ago, I mean, you saw Chris Richardson's talk today morning. It was an awesome talk, right? We happened to work with Chris Richardson like a couple of years ago when we started our microservices architecture style journey in Capital One. And fast forward 2 years now, we are big time in adopting cloud for our applications, and we are developing our apps as a collection of microservices using microservices architecture style. And what this leads to is distributed applications and microservices running in the cloud. And when it comes to cloud and microservices, all these distributed systems, failures are given because of all these systems in a distributed nature, right? So, and this is where we develop this chaos automation tool that helps to disrupt your applications intentionally and gain strength from such disruptions. That is what we are going to focus on today's talk.
Hi, thanks. This is Sathiya, enterprise architect at Capital One. So, in the last few years or so, large enterprises, governments, healthcare industries, a lot of them are aggressively adopting cloud. Some of the main benefits coming from the cloud is, faster, time to market. You get more capacity real quick, better automation tools and APIs that can provide you much more agility. But definitely in more cases, cloud provides much more resiliency and flexibility than managing your own data center. However, failures are inevitable, unavoidable, and it poses risk to the systems. There are a lot of failures, that are beyond our control. You might have heard about, Amazon's S3 outage not too long ago. That was, the systems were unavailable for 4 hours or so. So tens of thousands of websites were impacted, and so some of the systems that were not impacted was, for example, Netflix was not impacted. That's one of those things we are going to talk about it. There are many aspects of failures, hardware issues, human errors. Many times human errors are attributed to the large cloud failures, network outages, disks crash and instances reboot. So are you prepared for all of those things? A lot of traditional approaches, we have testing tools that test availability of systems and resiliency of systems, but are they sufficient in this case? So traditional test cases do not validate all the test cases. Typically they validate the happy path. Traditional testing tools are not really capable of testing all kinds of cloud failures. For example, somebody can manually go and reboot a server, but it's not a scalable solution. So we need much more automated solution, to test a large system. Sometimes, you look at a system, you look at a large application as a system and start inducing failures. Not all the failures may have an impact on the customer experience. As you start inducing failures, you will see at some point it could be a customer, experiment. It could be a customer dissatisfaction. In many times, you do a test case and it is valid this week. Maybe it's not valid next week. As you do a next release, at that time, whatever you have tested may not be valid. So even if you experiment in production, unless you have a repeated way of doing this every day, every week, every month, it is not really scalable. So this is where we have written Cloud Detour, which is inspired by Netflix's some of the cloud resiliency tools.
All right. So when we talk about chaos engineering and when we talk about cloud, Netflix open source tool Chaos Monkey definitely comes into picture, and we started looking into how that works and many other open source tools available in the market. And for a very large enterprise like us, where we have hundreds of applications, we wanted to have certain capabilities that are missing in the open source tools that are available in the market today. And some of the things that drove us to develop our own chaos engineering automation tools are these reasons. Number one, they use like archaic technologies, like some of the tools uses SimpleDB, we say cloud database, which is either deprecated by the cloud provider itself, or it uses some archaic technologies, right? And we want to have the ability of providing the fine-grained capability to selectively disrupt the targeted resources and have configurable disruption types and disruption schedules. This kind of fine-grained ability to go and disrupt your resources is not available in the currently available tools in the market, right? I mean, when I say market, in the open source market. And in AWS is kind of the cloud today, and our application uses different types of cloud resources, like auto scaling groups or Docker containers that runs on ECS cluster or S3 buckets or RDS, many different types of cloud resources. And we want to have the ability to go after all or any of these cloud resources and not affect only one type of servers like our auto scaling groups. We want to have the ability to attack different types of cloud resources, right? And last but not least, we wanted to run our solution using serverless technology. In the sense, we don't want to be running infrastructure to run our chaos engineering tool, right? So our first preference is not to run any persistent infrastructure, and we leverage AWS Lambda, which is a serverless technology, to run the Cloud Detour tool itself. And then we will have the applications subject to disruption by subscribing for intentional disruption, right? So chaos engineering, right? What is like the discipline of chaos engineering? Chaos engineering is roughly defined as experimenting on your applications by intentionally disrupting it and seeing how the application performs by gaining strength from the disorder, right? So here is a bird's eye view of the Cloud Detour tool that we have developed that helps our applications automate chaos engineering testing, right? So on the farther left hand side, what you see is number one. That is where the application user experience is. There are two user experiences. One is the application user. The other one is the Cloud Detour tool itself. As an admin, how do you install? So as let's say I am the Cloud Detour admin, I go run my automation tool to install the tool itself in a cloud provider environment. And in our case, AWS is our cloud provider. We install this tool in our cloud provider in AWS environment. And as you can see, the components that we use for Cloud Detour tool itself is all mostly serverless components. We use Lambda functions for running the logic of disruptions, and we use RDS for storing our state. So that's the Cloud Detour admin per se. We install this in our AWS account. Cloud Detour admin installs this, and that is available. And then comes the applications, right? So let's say we have 100 applications, and each application has an application owner, and this is the user experience of an application owner. On the further left hand side, the application owner goes and prepares a Cloud Detour request describing their application. They're going to go and say, this is my application, and this application uses these cloud resources, uses like auto scaling groups, EC2 servers, runs Docker containers, runs S3 buckets, or runs RDS. You specify your application ingredients in your description file, and you give that information to Cloud Detour tool. Cloud Detour tool takes that one and looks into saying, oh, you have these resources that you need your application, and it's going to send a notification to the application owner with our internal systems knowing this is the cloud resource, and this resource is marked, this person is marked as the owner, and then an email notification would be sent to that person, and the person receives the email. So yes, I am requesting for disrupting this resource, one-time approval. I'm going to approve that one. Once that application owner approves, then comes the disruption. We are going to schedule disruptions based on the disruption type that is selected by the requester, and it's going to go and start disrupting that particular cloud resources that your application uses. Now, you are actually disrupting your application intentionally, and that is how you are creating chaos in your application. And we encourage this adapting your applications to subject to cloud detour, aka disruptions, intentional disruptions, earlier in the life cycle of your application development, so you uncover the vulnerabilities that your application may have, and you catch it early on in the development life cycle rather than catching your application's failures or vulnerability at the worst possible moment in production. So that is what you get to do this one, right? So on how an application, moving on to the next slide, how like so here are different types of application disruptions, or here are different types of cloud resource disruptions that you can cause using the cloud tool. I will have Satya to walk over this one.
Yeah, if you are familiar with Amazon Web Services, most of these terms will be known to you. I will go through a couple of them so that you have better understanding. Fail ASG means fail auto scaling group. Auto scaling group is feature in Amazon Web Services where if an instance goes down, Amazon will automatically bring it back, or you can scale up and down as you need more capacity. So whenever an auto scaling group, an instance goes down, Amazon automatically brings it back. But your application is already configured in that server, and will it come back gracefully? It's going to take 3 to 5 minutes before you can have that application up and running in that server. In that case, do you have your load balancers properly distributing traffic across all the instances, or do you even have enough capacity? So what happens if an auto scaling group, one of the instances you lose during the peak? So do you have enough capacity? So what do? Can you manage that 5 to 7 minutes of downtime of one server? That is one aspect of failing an auto scaling group. Failing an EC2 instance itself is like sometimes you may have a servers that belong to EC2, but they do not belong to an auto scaling group. So in that case, if a server goes down, what is the impact of your system? Failing ECS means ECS is Amazon's container management system. EC2 container management system, it manages Docker containers. So when Docker containers goes and come back, how do you survive those failures? Elastic cache is their caching systems. So when failure happens on these systems, do you handle it gracefully? So if you look at this, Cloud Detour currently implements the first row of disruption so far. There are other things which are work in progress. For example, hogging CPU in a specific instance. So increasing the CPU many times results in poor response times, leading to latency, eventually crashing of servers. So your overall system, can it be immune to increase in CPU of one server? What happens if your log files fill the disk? So Cloud Detour will have the features to fill your log files and test, does it crash the disk, or you have a log purging system that you automatically take care of. There is a kill processes. For example, if a process goes down because of out of memory or something, does it comes back gracefully? Do you have your startup scripts automatically bring your processes back? There are more than 40 available services, highly available services in AWS. So by design, most of these or all of these services are very highly available in AWS. But are we designed to use it in the right way? For example, AWS provides multi-region deployment. You can deploy it in US East and US West. So if US East goes down, can you all handle the capacity in US West? Are there any dependencies in US East which you uncovered? So we will be able to use Cloud Detour to flip the traffic, all the traffic back to, for example, US East to US West, or disable one region to see the impact of one region being unavailable. So most of these are simulations that almost provide you a feel like as if you had a real outage.
Right. So what we see in this slide is an example application that is going to subject itself for Cloud Detour disruptions. Here, at the top of the screen, what you see is a section just describing your application metadata as to what is the name of your application, who is the application owner, and who is requesting for this disruption. And in the next section, what you have the cloud resources, that is pretty important. That is where you are going to say what is your resource type, right? What is the type of resource you are using? In this case, I'm saying I'm using auto-scaling group in Amazon Cloud, and you identify that resource. And you, for that cloud resource, in this case, auto-scaling group, you say this in a web tier, and that's the identification. And you choose the disruption type. And here we have like this random stop as the disruption type. Likewise, for each cloud resource, we support multiple disruption types. You can do like randomly choose one of the machines from the auto scaling group, stop it or terminate it or reboot it. And either you see the resource type is auto scaling group. Likewise, what Sathiya was showing, we have different types of cloud resources like the EC2 container service, which is like a Docker container orchestration service there, or like you use Elasticache, or you specify different types of resources. And then you choose disruption schedule, and this schedule says every day afternoon 2 o'clock, I'm on a business days, Monday through Friday, I need to disrupt my application. So you get to know how your application is performing on a daily basis when the failures are going to happen. And in this example, what you see is a simple disruption type. Likewise, you can induce many different types of disruptions for your application. And you can notify what is where do I want to send notification to when I disrupt my application. And that is what you say in the resource contact field. So this is an example of how you describe your application, and you are choosing different types of disruptions for the cloud resources your application use. And you take this one and you use our CLI tool to submit a request. Here is our CLI tool. And what the CLI you take that JSON file you prepared and you do register, right? Register, give my file. It's going to take your application request and submit it to the cloud Detour in the backend, and it's going to send notification to the application owner saying, I got this request, do you approve? And the application owner gets an email saying approve or decline. Let's say like an application owner approves, then the disruptions are scheduled for all the cloud resources that you have selected in your application. And when that time comes, the disruption schedule in this example, what we saw was 2 o'clock in the afternoon, it's go and disrupt your application resources. And your application, if it is built resiliently, if it is using high availability techniques as part of application development, then it will do well. Otherwise, you will going to have a disruption or outage or degradation of your service, which you will catch on a daily basis. And the idea here is have all these things done early on in the life cycle. On production, when you turn this on, there should not be any degradation to your application, and that is what we call like anti-fragile applications. When the disruptions happen, there is built-in resiliency that takes care or that addresses those things. And here is a quick snapshot of what are the different things you can do using the Cloud Detour API or CLI, right? So you can go and say, hey, give me all the applications that or registered in Cloud Detour. That's the get app IDs. It's going to get everything. And let's say like in the previous example we saw, you gave an application name. Let's call it as customer app. And you can go and say, get me all the resources, cloud resources, and all the disruption types that I use for my customer app. That's the CLI command you use, and you get all of that one. Likewise, you have the ability to use the CLI and find all the disruption events that have happened for a given resource, all the activity logs, who approved it, who did not approve it, all of that information. And then importantly, you know you are going to have a maintenance activity and you don't want the disruptions to happen. Then you can go and use suspend CLI command and make a suspend my disruptions, and it's going to stop all the disruptions. So you can take care of your maintenance activity, whatnot. And once you are done with that one, you can go back and say resume, and it's going to turn the disruptions back on. So this is like, and for finally you say, you know what, maybe I'm decommissioning my application. I don't want to have any disruptions going on. You can do like unregister. It's going to unregister your application from disruptions. So this, what you see is like an application owners just by click of a command can subject their application for different types of disruptions and gain insights and uncover vulnerabilities of their applications for different types of failures during their life cycle of the application development. And when the application goes into production, many of these things are taken care, and you don't have to deal with the issues in production for different types of failures.
On the final notes, so our goal is to get all the most of the 80/20 rule. So basically, cover most of the popular features in AWS, which is in our which is in the works. We expect to open source this upon successful internal adoption in pre-production and fully in production, possibly towards the second half of the year. And you saw that we have been using Amazon's RDS, and we have some APIs written to support this. So Amazon has DynamoDB, which is their NoSQL database. We are waiting for features like encryption at rest. So the system will significantly improve and less maintenance to run when we use Amazon DynamoDB. And API gateway support. You saw that we have a JSON file which you use S3 bucket as a way to introduce disruptions. Providing an API gateway support will leverage continuous integration pipelines and automation tools to interact with the cloud Detour with an API. Finally, multi-cloud abstractions. We have the principles and working in AWS. Our goal is to have abstract this to a higher level and make it usable for, like, say, Amazon, like AWS will use it in Microsoft Azure or Google compute engine. That is in our goal. So with that, we will open up for any questions. Also, we'll be here around after the presentation for a little while.
So all of this in your presentation, you are primarily focused on AWS cloud service. What about now all the applications? We're not only using applications, we're using the cloud service providers like Salesforce, Zora, and so we just give you an example. How do you integrate this kind of cloud service into your cloud service management?
Yeah, the question is, how do you use these principles to use in other cloud providers or SaaS providers? There are even questions about how to use this inside the data center. These are higher level architectural principles. Chaos engineering is a larger discipline. We have the principles and design which will be open sourced. So we should be able to develop similar. This is specifically designed for AWS. It will be extended to other cloud providers, but if you want to use other SaaS providers, for example, Salesforce in this case, we should be able to integrate with their adapters to simulate these kind of failures, similar design patterns and APIs in there.
So in practical reality, did you already done anything to cover some cloud services in your business?
That's right. This is targeted towards cloud services deployed. Yeah.
Is Pivotal Cloud Foundry on your roadmap?
The question is, do we have Cloud Foundry on our roadmap?
Yeah. So again, like Sathiya was mentioning, we have two layers. One is a abstract layer and the implementation layer. On the abstract layer, we should be able to implement for any cloud providers. And as we speak, we do not have Cloud Foundry in our roadmap. We have the implementation layer specific to AWS, right? And we have that abstraction layer where you could implement that for other cloud providers too, and Cloud Foundry could be one. And at some point when we open source this one, that's where if there are demand for such things, somebody could implement that particular layer.
But you haven't had necessarily talks or communication with the contributors that were interested in doing this?
So it is not open sourced yet. So this is inner sourced, meaning within Capital One, we are driving adoption for many applications, and we don't use Cloud Foundry now. So there isn't a demand. And once this is open source, then we should be able to gauge the demand and take further steps. Right,
Thank you.
Thank you.